A very good morning to all. A warm welcome to the third day of our FDP. So today morning we will continue our hands-on session on Python, and afternoon we will see optimization algorithms for image processing. Our resource person will join soon. So please stay with us. Our resource person joined, so we can start our session. Asli.
A very good morning to all. In yesterday's hands-over session, we familiarized with the basics of Python programming. Now, all we have a clear idea about various platforms used for compiling, variable declaration, error correction, etc. Today, we are going to do a few advanced experiments using Python. I hope all are ready. Jayadev sir, on behalf of entire participants, I welcome you sir.
Okay, thank you. Uh, I hope I'm audible.
Yes, Jayadev.
If you can, okay, thank you. And I hope my screen is also visible.
Now it is visible.
Okay, so welcome to day 2 of the Python hands-on workshop. Just to recap the previous day, we looked at the basic data types and how to perform certain operations within it. And for today, we will look at functions, modules, and then we'll get into examples. So, like yesterday, if you want to do hands-on with me, kindly log into Colab. Network is taking a bit too long to load. That's okay, I think. So, after completing functions and modules, we will go through an example of how to import images into Colab. The same can be done with any other IDE. The only difference is in mentioning the path, and I will show you how to do that. And I will also show a demo of a project that I did in ASAP, which is for mask detection. So this is yesterday's file. I'm going to continue here itself. Okay. If you didn't know, we can change the name of our file by just clicking here and editing it to any name that we want. Python workshop. So today we'll start with functions. So functions are variables which does some action on the data which is provided. So when a variable is given some action to be done, then it no longer becomes a variable, but it becomes a function. That's the most simple way to understand what a function is. And a function in Python is defined using the keyword def. If we want to declare a function, we first put it def and then function name within a parenthesis and a semicolon. That is the syntax of how functions are defined. And we will write a simple function to print something like def and then a function name, and we'll give a parenthesis, and then a semicolon. Then we press enter. We can see that the indentation comes correctly, and then we put the actions to be done. Like in this case, we are printing something, so print in parenthesis what we want to print. Like we run that. So what it does is it will define a function called fun name, and if we call that function by fun name, it will print test. So if we need to write a large program, we would be using a lot of functions, and to keep track of what does what, we will usually recommend what is called as a doc string. So it will act as a help or a guide in letting us know what that particular function does. It is a description of the function, the purpose and its behavior. So we can write a doc string by, let us take another example. See function 1. Let us pass a parameter s semicolon. Then we define a doc string by 3 quotation marks. Then we put print a string s and tell how many characters it has. So that is what our function will do. It will print a string and tell us how many characters that it has. So this is how we define a doc string. Now I will write the code to print the string and to display the characters in it. We do that by print s s s. We give the len of string. I hope you remember from yesterday. Len of s was a command to print out the number of characters in it, and we give it as a string so as to match the other variables in the print statement. So now we can check whether our doc string function works by help and then giving the function name. So here it clearly says that this function prints a string s and tells how many characters it has. Okay, collab is okay. So I will test this function by 1 and then passing a string like how are you. Here it prints the string how are you has 11 characters. So that is how you write a function and write a doc string to define what the function is for anyone looking at our code at a later point of time. And while writing a function, there is a very efficient method to get some value out of it by using the keyword called as return. For example, if you want to write a function to suppose find the square of a number, we put def square of that variable be x. So x is the parameter which we will pass, or the variable which we will pass. Then return x squared. So we wrote the function. Now we will test whether it works. Square of 3. So when we call the function, it will return the square of the value given as the parameter. So 3 squared is 9. And also there's an option for returning multiple values from a function using tuples. So for example, we need to find the square, cube, and the power of 4 to a particular function. So we define it by def powers of, and then the variable name, semicolon, and we return the square, comma, the cube, and the quadruple of the variable x. So we have defined the function, and now we will call the function with a data, let's say 3. So that will return the power of 3. Oh, sorry, I gave the function name wrong. It is powers. So we get the power of x 2, 3, and 4 as a tuple, and the answer is 9, 27, and 81. And suppose if we want to store the individual numbers of the powers to certain other variables, we can do that by putting, for example, x2, comma, x3, comma, x4. x2, x3, x4 are just variables in which we want 9, 27, and 81 to be stored. So we will equate it that to our function class of 3, and if we print x2, it will contain the value of 9, and similarly if we print x4, it will contain the value 81. So we can assign the output, the multiple output, to individual variables as so. Now there are certain default arguments and keyword arguments. Like yesterday we saw for list, I made one, two, two. For a string S, to print the first characters, I made it like this. And then later I showed you that if we put it like this, then this third thing is called a step. So we didn't mention it in the first thing because the third part was an optional thing, and the default value for it will be 1. It is like a default argument or a default parameter. So we didn't need to define it then. So in a definition of a function, we can give default values to the arguments the function takes. So when we are defining a function, let us see how to give a default argument. Like if we give 2 arguments, then it should act in some other way. So we will see an example of that. We will define a function called my function. Let us say it will take parameters x, and then one p equal to 2, and we will put debug equal to false. So, and we say if debug, then print evaluating my function for x equal to string of x plus using exponent p equal to plus string of p to x raised to p. So for this function, if we don't provide a value of the debug argument, when calling the function, my function, it defaults to the value provided in the function definition. For example, if we call the function my function, say 5, it will return 25. And if we put the default function as true, as in the default is false, so in that case, my function of 5, comma, debug equal to true. We are changing the default argument here. So now it will go into this if loop and do this what we have defined here. So evaluating my function for x equal to 5 using exponent p equal to 2, and it gives 25 as the answer. So that is a basic example. Now, if we explicitly list the name of the arguments in the function call, we do not need to come in the same order as in the function definition. This is called as keyword arguments, and it is often useful in functions that take a lot of optional arguments. For example, in this case, my func p equal to 3, debug equal to true, and x equal to 7. So we can see that we had given only one thing, which is the value for x, and the other things are defaults. So when we actually define it for the function, the order of the variables given doesn't actually matter when we do like this. Now also within function, there is a thing called as lambda function, which is an unnamed function. We can use it to temporarily create a function, but when we don't want to name it, we do this by using what is called as the lambda keyword. Like, for example, f1 equal to lambda. Lambda is the keyword x So what I've just written now is equivalent to so these two things, the one in line 40 and line 41 is the same thing. So let us experiment it by giving the same values to both. Let's say for F1 we give the value as 2, and for F2 also we give the value as 2. Both will return the same number, which is 4. So that is a very easy way to write a function with what is called as an unnamed function. So here this is same as this, but this looks more convenient. So lambda is not generally used, but it is good to know that such thing exists. Now I think we can move on to classes. Classes are the key features of object-oriented programming. This can be called as a pillar of object-oriented programming. A class is actually a structure for representing an object and the operations that can be performed on the object. In a Python, class can contain attributes such as variables and methods. That is also called as function. A class is defined almost like a function using the class keyword. For a function, we use def, and for a class, we use class. And the class definition usually contains a number of class method definition called as a function in a class. Each class should have an argument self as its first argument, and this object is a self-reference. So let us define a class called as point. We do that by keyword class and then the class name. As I've said in yesterday's session, class name will often start with capital letters. Now we give certain function. Let's say def underscore init underscore self y. So underscore init, the name of the method that is invoked when the object is first created. So we create a new point at x and y. We do that by self dot x equal to x and self dot y equal to y. Now let us write another function called translate, which translates the point by dx and dy in the x and y direction by def translate self comma dx comma dy. We put self dot x equal dx. That is, we increment the value of x by dx, and similarly for y, self dot y equal to dy. And we write another function called as underscore str. It is a method that is invoked when a simple string representation of the class is needed. For example, when like printed. So we do that by def underscore str underscore self return point at def teacher. Self dot x comma y. So that is run, and now we try creating a new instance of the class. I know that most of you would be off track by now, but try to focus. This is actually very simple. It might seem a bit complicated now, but eventually you'll get the hang of it. E1 is equal to point of, let's say, 0, 0, 0, 0. So what this does is it will invoke the init method in the point class, which we just defined. So, and then we'll put print p1. So this will invoke the underscore str method. So this is how we do it. And to invoke a class method in the class instance P, we do that by P2 equal to point 1, 1 put P1 dot translate, and then we give the values for dx and dy, which is 0.25 and let's say 1.5, and then we'll print out these two by print p1 and print p2. So we will get the output. Note that also do note that calling class methods can modify the state of that particular class instance, but it does not affect other class instance or any global variables. That is one of the really nice things about OOPS design. Codes such as function and related variables are grouped in separate and independent entities. I think that's a good example for a class. I know most of you would have not understood it, but I will give this material to you and you can refer it out later. Now I think we'll skip to modules. So I think we'll understand more about the class when we go through the examples. So some of the most important concepts in good programming is to reuse code and avoid repetition. So the idea is to write functions and classes in a well-defined purpose and scope, and then reuse this instead of repeating similar code in different part of a program. So this concept is called as modular programming, and the result is usually that reliability and maintainability of the code is greatly improved. What this means in practice is that our programs have fewer bugs, easy to extend, and it is very easy to troubleshoot any problems. Python supports modular programming at different levels. Functions and classes that we discussed just now are examples of tools for low-level modular programming. If we get an error in any of these, we would know where to look. So Python modules are a very high-level modular programming construct where we collect related variables, functions, and classes in a module. A Python module is defined in a Python file. As I said yesterday, the Python file will have a extension of it, and it can be made accessible to other Python modules and programs using the import statement. Right? By now, you would have seen certain files which would have like import something, like import TensorFlow. So we will consider the following example. The file mymodule.py contains simple example implementation of a variable function and a class. So we do that by percentage file my view dot UI. This is example of a Python module. It will contain a variable called my variable and a function called my function and a class called as my class. So we will define it. First, we will put the variable, which is my variable, and we'll just put a value of 0 to it. Then we'll define the function by the def keyword. We'll name it my function. And let's say this function will return my variable. Okay, so we have defined the variable and the function. Now let us go and define a class called as my class. We do that by the keyword class followed by the class name my class in the parenthesis and one. So within the class, we will give the init function and the set variables and the get variable function. So let us do that. Def underscore init underscore self and then self dot variable equal to my underscore variable, and then we define the second function, which is called as the set variable by set underscore variable and self new value and self variable equal to new underscore value Now we will write the get variable function by def get variable self semicolon return self variable. So we can see that we got the output here as writing my module.py, and this we have written our module called as my module. Now we can go ahead and import the module, which is called as my module, into a Python program using the keyword import. Import my module. So now the module that we just wrote containing these functions and these classes, and inside the classes these functions have been imported to our program. Now we can use everything which is here for any further. Suppose let's say we do this for one of our projects, and then later we need the same thing for another. So instead of writing the whole thing, we can just import our module as such. So it is a very simple concept. Don't feel a bit off track. This is kind of an advanced topic to write modules, but this is a very useful thing if you are regularly writing or experimenting with Python programs. And as I said, if we had given the doc string for each thing, we can refer what everything does by putting help and within parentheses the module name. So let us actually verify whether everything we did is correct by, let's say, printing out the variable, which is my variable. We do that by the module name dot the variable name. Our module name is my module. We can see that it is coming in auto suggestion. I'll type that anyway. Module dot my underscore variable. I will go and run that cell. So my variable has a value 0. So it will define the value 0. Now, similarly, if we want, we can call the functions within our class. Maybe we can try that later. So how we do that is by defining my class equal to my module dot my class, and then we call the functions by the my module dot my. Okay, maybe I'll just do that. Let us define a variable called as my underscore class, which will be equal to the module name, which is my module dot class name, which is my class, and then the parenthesis. So what we did here is we assigned the full name of my module dot my class to the variable called as my underscore class. So now we can call the methods within my class by my underscore class dot set underscore variable of, let's say, 10. So if we hadn't given my underscore class, we would have to type the full thing, my module dot my class dot set underscore variable. Set underscore variable is the function which we defined within my class. We'll also do the get variable method so that we can print it my underscore class equal to, okay, not equal to dot get underscore variable. So now we will get the output as 10. Yes. So if we make changes to the code in mymodule.py, we need to reload it using reload of mymodule, but that only works in Python 2. The version that we are currently using is version 3.9 or something. So if we are using that, then we could try that. Now, next we will move into exceptions. So I have shown you how to manage errors in Python. So the explanation that comes with an error is often sufficient to understand where the error is and what is the error. And Colab also provides an option to connect to Stack Overflow, which is a very popular forum to discuss and analyze any programming concept and all the underlying problems and how to correctly implement such things. So in Python, errors are managed with a special language construct called as exceptions, similar to what is in Java only. So when errors occur, exceptions can be raised, which will interrupt the normal program flow and fall back to somewhere else in the code where the closest try except statement is defined. So to generate an exception, we can use the raise statement, which takes an argument must be must be an instance of the class. So base exception or a class derived from it. So when we write a function or a module by ourselves, if we get an exception and we already accounted for that, we can add it in our code so that the person who use what we did can easily diagnose and troubleshoot it. So we do raise then exception. Then we put the description of the error. What it will do is give out the explanation that we give. If at a particular flow of our program, the data type or the flow isn't moving as per our expectation, we can add the symbol statement so that the user will get this output and will know what to do. This is actually given by us. Okay, so a typical use of exception is to abort functions when some error condition occurs. Like, for example, let's define a function called as my function, my underscore. And we give some arguments, let's say arguments itself here. And let us give an if loop, like saying if not verify arguments, then they will raise an exception called as invalid arguments. So like if verify arguments, raise exception as invalid arguments. So, and if we need to write something, the rest of the code will go here. Code. So I'm not going to do that now. So this will be the flow of how exception should be dealt in our code. Now, to gracefully catch the errors that are generated by function and class methods or by Python interpreter itself, we use the try and except statement. We do that by try and some conditions goes there, conditions or our code goes here, and then we put an except statement, which is except, and then we go here, we put the code for handling error. So this is the general structure. This code under except will not be executed unless there is some error within the code in try. That is, when this generates an error, this will execute. Okay, maybe we will see an example for what I mean by this. Let's say if we print string called as s, and if that is giving an error, under except we will give print what an error. So when we run it, we will get test. But however, if we delete the quotations, now what will become is test will move from a string to a variable. So we haven't defined a variable called as test. So it will move out of the try block and will enter into the except. So it will say that it caught an error. So that is the logic behind try and except. Now, to get information about an error, we can access the exception class instance that describes the exception by using except exception as e. We will see what that means. Let's put the try and then print s, and within the same thing we will give it as a variable name test, and then except exception as e, and then we'll print hot and exception. Okay. So what it will do is it will print the first test because it is given as a string, and then it will try to print the variable test. So we haven't defined the variable test before, hence it will give an exception. So then it will move into the except statement and give this output as expected. So now we will take a 10 minutes break. You can put any questions in the chat box. We will return at 11:10. Okay, yes, I think most of you are back after the short break. Uh, Now our syllabus has almost been completed. Now we will see on how to handle images. Um, there are a lot of different libraries which support manipulation of images and videos. Some of it are NumPy. It is an array manipulation library which is mainly used for linear algebra, Fourier transformation, and random number capabilities. So Pandas is a library for data manipulation and data arrays. CV2 is a library for computer vision tasks. skimage is a library which support image processing applications on Python. And MATLAB is a library which figures and provides graphical user interface toolkit. So usually I have worked with the Matplot and OpenCV, but recently when I tried to import images using OpenCV, I was getting some errors. Apparently, some things have changed from when I actually tried working with OpenCV. So I didn't get enough time to figure that out. For now, I will show how to load images into Colab or any other environment for that matter by using Matplotlib. So Matplotlib is a visualization library in Python for 2D plots of arrays. So yesterday we have seen what is list, okay? And so what is array? Array is like a list, but it contains data of the same data type, and it occupies a continuous memory space. So that's the difference between an array and a list. So Matplotlib is a multi-platform data visualization library. It is built on what is called as NumPy, which is numerical Python arrays, and it is a very widely used library. So we will look how to do that. We have seen how to import modules. Matplotlib is a module, and we need certain functions from that. We do that by statement or keyword import matplotlib dot image as we import matplotlib.image as emping. That is, whenever we need to use matplotlib.image, we just give the name mpim. That is matplotlib image. That's like a short form for it. Now, yeah, we can see a brief description. It supports basic image loading, rescaling, and display operations. Now, to plot it, we will import something called as the pyplot from matplotlib. We do that by the import statement import matplotlib dot pyplot as plt. We import only certain functions from matplotlib because we do not want the entire matplotlib module to be imported, because that's just unnecessary wastage of resources. We only need this, and hence we are only importing what is needed. So images can be taken either from the internet directly, or we can take it from our local drive. In this case, since I am running this on a Google Colab, I will connect my Colab so that it can read images within my drive. So I do that by, we can do that by going to this option here. Let's taking a bit of time to open. So we will expand that, go to this folder icon here and press this actually. I had earlier tried mounting my drive, so it's showing a cross mark here. If you're doing this for the first time, you will get a folder icon with a very small icon of a Google Drive. Once you click that, you will mount your drive to the Colab. And within this drive, you could see a folder called as My Drive. And within My Drive, you could see everything that you have stored in the Google Drive. So we can import the images in our drive directly to Colab this way. It will take a bit of time to load because I have a lot of things in this particular account drive. This imRead is the function that we will use to read our image, and within this parenthesis we will give a path. This path can either be a URL or it can be the location of the file. We'll just, I'm taking a random image and I will paste it here in quotations. So a path within the drive will appear like this. That is probably evident from where it is located. /content /drive /my drive, and within my drive it is pointing to this particular image. So when I run that, what it does is it will read the image from this location and save it to the variable called img. Now to show that img, we use matplotlib pyplot. We do that by plt because we imported matplotlib.pyplot as plt. Plt imshow is the function used to show the image, and the image is saved in img. So when we run that, it will give this image and certain values. Now there are a large number of operations that could be done for this, like cropping, rotating, inversion of colors, and a lot of other things. So I will probably send you a reference material on how to do all that because I didn't have the time to try it out myself. Now I will, similar to matplotlib, there is another thing called as the Python imaging library. It provides a Python interpreter with image editing capabilities. So now I will try loading the image with PIL. For that we import it from PIL. I haven't tried this before, but import image. Okay, that L should be capital. PIL stands for Python Image Library, by the way. So we read it from Python Image Library using
So I think Mr. Jayadev has some issues with his network connections. They will come back within few minutes. Mr. Jayadev is trying to rejoin with us, so please stay.
Yes. Hello, can you confirm if you can hear me? I think I am audible. I had a little issue with my internet. I have connected with the different data source now. That's all about images. I will send you a detailed article. Now you can see how about my face mask detection program. So before that, I would like to show how to write a very simple uh, neural network program, or what is called as a perceptron. Like now, I think we can write a hello world of the deep learning with neural networks. So first, we will start something with very simple, and then we will look at how I did my ASAP face mask detection code. So first of all, like I said, we need certain modules to be imported. We will start with importing TensorFlow, and we'll call it as TF which is a very standard notation widely used. And then we will import a library called as NumPy, which will help us to represent our data as lists quick and easily. Let us import TensorFlow by import TensorFlow as PDF. And then we will import our NumPy as import NumPy as NP. So instead of the word TensorFlow and NumPy, we can use TF and NP respectively. Then the framework for defining a neural network is a set of sequential layers that is called as Keras. So we import that too. Keras is a high-level API of TensorFlow. So from TensorFlow, import Keras. We will import that. Now we will go on and define and compile our neural network. I'm sure you would have seen a lot of things about neural networks, and most of you are more than familiar with the concept. But for those of you are beginning in this, I would like to set a base. That's why I am showing this. So now we will name our model as model equal to. So our model will be the simplest possible neural network. It will have one layer, and that layer will have one neuron, and the input shape to it is just one value. So we do that by equal to tf dot keras dot sequential. We are building a sequential model, hence sequential. We do the layer and the neurons by keras dot layers dot. Dense is a word used to denote the interconnection between neurons. This is mainly applicable when we have multiple layers and multiple units within those layers. So here we will just define unit equal to 1. The input shape will be just 1. So input underscore shape equal to 1. Okay, so we have defined the model. Okay, it is not units. It is not unit, it is units. My bad. So we can see how I read the error. It was self-explanatory. So now we will go ahead and compile our neural network model. When we do so, we have to specify two functions, a loss and an optimizer. That is, a loss and an optimizer are the parameters with which our model will try to behave in the way that we intend. So I'm sure you would have seen a lot of math for machine learning, and here's where it is usually used in defining the loss and optimizer, as in computing a very good loss and optimizer. So in this case, it is nicely encapsulated in functions. So what happens here is that let's say the relationship between numbers is y equal to 2x minus 1. When the computer is trying to learn that, it makes a guess, right? Maybe it will start with y equal to 10x plus 10. Then the loss function measures the guessed answer against the non-correct answers and measures how well or bad it did. Like if our actual value is 2 and it predicts as some 300, then the error is very large. So it will try to minimize that error. That is what the loss function does. And then the optimizer function will try to make another guess based on how the loss function went, and it will try to minimize that loss. At that point, maybe it will come up with something like y equal to 5x plus 5, which is pretty bad, but still close to the correct answer maybe, which is 2x minus 1. So in the case of 5x plus 5, the loss is a bit lower. So this will continue repeating itself for the number of epochs or the number of iterations that we give to it. So here's how we define the error by something called as the mean squared error. That is the square of the mean of the errors. That is what is meant by the mean squared error. And we will put the stochastic gradient descent as the optimizer. Like gradient descent can be understood as a person coming from the top of a hill to the bottom. A person can take many paths, but he will probably take the shortest path between the top and the lower one. Now imagine that the hill is a contour and the highest point, which is at the top of the hill, is the error and the lowest point is the optimum value. So he will try to come to the lowest point, which is the optimal value. So it can be understood in that way. We don't necessarily need to understand the math for this yet, but we can see how this works. Over time, maybe you'll learn the difference and appropriate loss and optimizer function for different scenarios. So let us go ahead and compile this model. We do this by model.compile, and then we put optimize. It should be Z, not S. Optimizer will be stochastic gradient descent. We put that by SGD, and the loss we will put it as mean squared error, mean underscore squared underscore error. So our model is compiled. So our model needs a data to work with. So next up, we'll feed in some data. In this case, we are taking 6, let us say it be X and Y. So we will be taking 6 data points of X and 6 data points of Y. And we will give the points such that their relationship is, as mentioned earlier, 2x minus 1. And so a Python library called as NumPy will provide a lot of array type data structure that are a standard way of giving data to the neural network. We declare that we want to use these by specifying the values as an np.array. I had earlier mentioned the difference between an array and a list. So let us put the access as arrays np.array parenthesis square bracket. Let us give some minus value. I have worked out the math beforehand. Since I'm giving it minus 1, 0, 0, 0, 3.0, then 4.0. So these are floats. We'll just mention that here. Type equal to float. So while typing itself, you can see a minute help that just pops around. If you want, you can read that and understand a lot of things. So now I will define the y's, dot array, then square brackets. I'll give the data points minus 3.0, minus 1.0, 1.0, 3.0, 5.0, and 7.0. Now, I am connected with my mobile data. I'm not sure how much of data is left, but if in case I am disconnected, I will try to send all the resources to you. And if I'm disconnected again, please take that as end of my session. Because it's taking the session. So right here, I have defined the data points as arrays. Now we will go ahead and train a compiled neural network. So the process of training neural network is where it actually learns the relationship between our data points X and Y. So we train it by fitting our data points to the neural network. We do that with model.fit. So this is where it will go through the loop we spoke about, which is the epochs, and it will make a guess measuring how good or bad is the loss using the optimizer to guess and to make another guess, etc. And this will continue. It will do it for the number of epochs you specify. When you run this code, we can see the loss in the right hand side. I will just go ahead and fit our data points to our model by model.fit. And the data is x's and y's. And let's say, since this is a very small model, I will put the epochs as 500. So what it will do is it will iterate 500 times and try to find the best fit. We can see the data here. See, here it will see the number of epochs. Now it's already into 200, 300 something. We can see the loss which is coming. Okay, and 500 epochs are completed very fast. So now we have a model that has been trained to learn the relationship between X and Y. Now you can use the model.predict method to have it figure out the Y for a previously unknown X. For example, if X equal to 10, let's see what it will give. Okay. So maybe we'll print it out. Print model.predict. Then we need to give the input as float. So if we give it as 10, since this is 2x minus 1, we should ideally get 19. Let's see what it shows us. So it shows us 18.98, which is somewhat close, but not the exact value. So if we maybe increase the epochs, then increase the epochs, increase the number of layers, increase the number of neurons within each layer, and we do such things, which is called as optimization, we might get the correct answer. But for a pretty simple neural network, this works very fine. And this value may be different for you if you are doing along with me. So always remember that the neural network deals with probability. So it calculates a bunch of value and it says that for 10, 18.98 is the best probable value. So given the data that we feed the neural network, it calculated that there is a very high probability that the relationship between X and Y is 2x minus 1. But we have given only 6 data points. So the neural network couldn't make it for sure that that is indeed the relationship. So as a result for 10, it is very close to 19, but not necessarily 19. So as we work, we will see this pattern recurring. So this is a very simple neural network for you, implemented in say less than 10 minutes, I think. So this is the model that I used to train my mask detection model. So what it does is it will read an image, our live image, and predict whether, not predict, it will say whether we are actually wearing a mask or not. That's why the name it is a mask detection model. So the first step is to make the model, since earlier we had given certain numbers, certain data directly there. But in this case, we will give the images of person wearing mask and person not wearing mask, and try to tell the computer by showing the image that this image, the person is not wearing mask, and in this image, the person is wearing the mask, and try to make the computer or the system or the model learn that what is a mask, what is a person, what does a person wearing a mask look like, so that when it later identifies, so that later when it sees a man, it can predict whether the man is indeed wearing a mask or not. So these are few of the modules and libraries that I had to import to do the model. I have done a method called as transfer learning, in which I use the base of a very complex, highly trained model and just modified it so that I can get the output that I want. The base model in which I have built on is called as the MobileNet V2, MobileNet version 2. You can read about that in Google. Image generator is it's like an padding thing that we use, in which if we don't have enough data, then the image generator will generate its own false data so that we have enough data to train a neural network model. As in a neural network model, as I said earlier, the much quantity of data that we have, the better will be the reduction of the better will be the prediction of our outcome. So Adam is another optimizer that is widely used. And while loading images, we have two sets called as the training and testing sets. What the training set does is to build the model with the data in the training set. And what the testing set does, what the testing set performs is that the model will try to predict the elements in the test set so as to make sure that the model is somewhat accurate. So I have loaded all the things here, and the images or the data set is saved in my drive in this particular location. This I did from a different Google account, and I can't run this because it will take an awful lot of time to actually run. So what this everything is called as the image processing, I need to convert it into my desired size. Okay, I got a message that my data is going to be over. I think I will stop now. If that's okay for you. So it's been a good 2 days. I will send you the remaining resources. I'm going to stop presenting. My data will cut off anytime soon. Thank you, and sorry for this abrupt stop.
So thank you, Mr. Jayadev. Thank you very much for this excellent hands-on session. So in his session, Mr. Jayadev demonstrated how to handle Python. He started from the basics yesterday and explained some advanced concepts like functions and classes today. For all participants of this FDP and entire EC department, I express our sincere gratitude. Thank you, Jayadev. Thank you very much.
Yeah, thank you, sir.
So dear participants, last session of our FDP is on natural inspired optimization algorithm for image processing handled by Dr. Shilpa Suresh. The session will start at 2 p.m. The feedback form of session 5 is shared in chat box.